Hello, everyone. My name is Louay Shaat, and as I've mentioned, I'm a security solutions architect here at AWS. I have been with AWS for the last 3.5 years. I started with AWS in Australia for a couple of years, and I've recently moved to the UAE. So today, I'm going to take about half an hour to talk to you a little bit about DevSecOps, specifically when it comes to containers. I know it's a big shift from the two previous presentations that you've had. It's going to be a little bit more technical, but it's going to focus a little bit more on the human element and how can we enable security as part of our DevOps lifecycle, specifically when it comes to containers. So what to expect from today's session? We're just going to talk a little bit about the AWS shared responsibility model and some of the security pillars that are associated with that responsibility model, and what does that mean for you as a customer when you start working with containers in AWS. I'm going to talk a little bit about the container security using DevSecOps and some of the threat actors that you need to look out for when you're building containers on top of AWS, and some of the open source tools from a container security perspective and some of the standards that we do expect that you do build. And finally, we'll talk a little bit about some of the development tools that are available for you in AWS. So quickly, before we kind of dive into the security side of things of containers, in AWS, you have multiple ways where you can build your containers and your container strategy. You can go with a self-hosted Kubernetes platform that you can run on top of our virtualized environment, or you can go with two of our managed services. We have ECS, which is our Elastic Container Service, and EKS. And if I don't want to spend too much time on this, but if I summarize the differences between them, ECS is mainly driven around simplicity. It's an opinionated way of running containers in AWS. We're using some proprietary software in terms of how we run the control plane. We're leveraging open source tools in the backend, similar to how you would run containerized workloads on your own. It's just that we're doing that on scale. The great thing about that is that we reduce the complexity of running containers on AWS, and we reduce the time for you to build, deploy, and migrate applications. But also, we've seen a lot of customers that want to benefit from the flexibility and openness of Kubernetes. And this is where we have Elastic Kubernetes Service, which is essentially our managed Kubernetes offering within AWS. Again, it offers you a secure, highly available control plane across all your Kubernetes deployments, and you also get to all the open source functionality that's available as part of Kubernetes. So before we kind of dive into the DevSecOps when it comes to containers specifically, it's important to understand where your responsibility lies and where the cloud vendor that you're going to be choosing lies as well across your stack. So as an example, if you're going to use our EKS service, which is our Elastic Container Service, you're going to see that AWS is responsible for security of a few of the components of your containerized clusters and some things that you are responsible for. So if you're going to go with managed node groups, essentially, which is EC2 instances that are running within your AWS environment, you'll see that AWS is actually managing the control plane for you, the API servers, the controller manager, the scheduler, etcd, kubelet, and a bunch of other configurations. You as a customer are still responsible and have the flexibility of doing your scalability, your network configuration, network policies, rollback access control, cluster scaling, managing your images and your source code, etc. So the only thing that happens is that you are responsible more on the client side, and the whole control side of things is being outsourced to a vendor. You can also go with Fargate, which is our serverless container offering. And with a serverless container offering, the EC2 instances are not even running within your VPC. They come to you as an offer, as a managed service. You're still responsible for the management across the cluster itself, but from an operating system to manage the instances, that's something that you can outsource to AWS or to other cloud vendors for that matter as well. So now that we've set the scene and kind of have a little bit of a basic understanding in terms of how some of the container services work in AWS, let's talk a little bit about the DevOps methodology. The previous talks, we talked a little bit about the whole concept of DevOps and digital transformation that happened and how that's been kind of enforced using with all the different changes that happened with COVID recently. I think the most important thing to realize when we're talking about DevSecOps is DevSecOps, even though I don't like the word so much, it's a great way to say that we want to embed security as part of your automation pipeline. Whether you're a developer, whether you're an operations person, or whether you're a security professional, the idea behind it is that you're following a pipeline in an automated fashion that gives you the ability to automate your security controls across the whole cycle from a development perspective. So if we take a typical DevOps cycle, we'd look at it from a build perspective. You have some static code analysis that you probably want to inject as part of your code. You want to do checks for secrets detection or leak prevention across that. When you go into the release, you put in your architectural guidelines, you build compliance, you vulnerability assessments. And then if you want to go from an operations perspective, you want to do secrets management and enabling security monitoring and compliance checks. And finally, from a vulnerability assessment and going through that cycle again from a testing perspective. So why am I putting this here? I think I'm putting this here for one specific thing. When we start talking about DevSecOps and embedding security as part of your DevOps methodology, the closer you are to the release, the more expensive security concerns become. And it's typically called shift left methodology when it comes to security as part of your DevOps pipeline. The closer that we are that we move security into the source and from a build perspective, the cheaper it is for us as an organization to be able to embed those security controls as part of our pipeline. And as you can see, though, later on that you need to do that, there's a lot of retrofitting, there's a lot of retesting, and a lot of re-releases that you need to do for you to be able to embed those security controls. And at the end of the day, that also starts with the developers. So as your developers are building pipelines and innovating on top of your platform and releasing new services, we need to ensure that security and DevSecOps is part of the culture that you build within your organization. As you probably know, with the whole DevOps shift that happened over the last 7-8 years, the idea behind it is that we're blending our developer and operations experience into virtual teams that work in harmony to be able to get those releases quicker to our end customers and innovate faster. Again, with that same methodology, you want to ensure that every single person in the organization tackles and understands security from day one. And this is a combination of tools, people, and processes. There needs to be a culture of communication that you need to build within your organization to ensure that developers understand the importance of security as part of your pipelines. Make sure that they have the right tools for them to be able to embed that within your tool sets. And also enable them and to be able to work with the security teams to get all these different controls in place. Besides that, you also need to work on establishing your level of trust. And what do I mean by that? When you are working with cloud vendors, you're going to have the ability to do things like encryption. And then within encryption, you also have multiple different options in terms of how you can encrypt your data and manage secrets across your environment. If you have a zero trust mechanism where you don't trust your vendors and you don't trust anyone with your data, you can go with customer managed keys as part of our key management service, or you can even implement your own hardware security modules as part of that. If you're 100% trusting your cloud vendor and you want to go with that level of trust, you can go with services like AWS Secrets Manager and use our key management service using AWS keys to encrypt your data. Typically, we see customers somewhere in the middle, where they have a certain level of trust with the vendors that they're working with, but also giving them the ability to secure the data outside of the vendor's workflow and lifecycle. Services like Cloud HSM gives you the ability to implement a hardware module that's running within AWS, where you can generate your own certificates and your own keys to ensure that encryption is happening out of band from a vendor perspective. Once you've established your level of trust, you can start selecting the right tools and the right services in terms of how you deploy your containerized workloads on top of a cloud environment. A really good example of that is if you have a zero trust where you don't want anyone to be involved as part of your container strategy, this is where you go with a self-managed Kubernetes platform where you run the control plane yourself, you run the etcd, and you run your worker nodes within your VPCs, and you get to manage the whole stack. Obviously, that comes with the additional level of complexity that you do have to manage that control plane and ensure the availability of these services. But we also see customers that go somewhere in the middle and leverage our managed services, our Elastic Kubernetes service. And the idea behind it is that us as a cloud vendor managing this on scale, we give you the ability from an endpoint perspective to connect to a control plane. And all you have to do is take care of your worker nodes across your environment, which is essentially the work that you want to be able to focus on in terms of securing your data, securing your environment, and securing how you actually release that code into your customers. And the great thing about these different, container services that we have from an AWS perspective is that we have native integration with a lot of other AWS services, specifically our security services. Another thing as well to point out is how Kubernetes works from an identity perspective. Kubernetes has its own authentication module by default. We have worked from an AWS perspective to integrate that with identity and access management. So the idea behind it, the people that are accessing your Kubernetes and your container clusters on top of AWS are authenticated using your identity. Typically, that comes in the form of your identity provider, things like Okta, which I'm a big fan of, or Microsoft Azure AD, or Ping, or OneLogin. And the idea behind it is that once you've federated into your IDP, you still have the ability to leverage that same identity across your containerized workloads. So whether you're doing deployments from an automated fashion using service accounts, or you have some operators that are logging into your cluster to perform some actions, you can govern that based on an identity level that's unified across your whole stack. With our integration that we've done, we basically have a CNI integration that happened with our Kubernetes open source that's been pushed back into the open source Kubernetes releases. And now you have the ability to integrate your AWS identity as part of that. And that's another really good mechanism from a trust perspective to ensure that whoever is managing your container workloads is also the same identity that you verified. You have the ability to add things like MFA or multi-factor authentication to ensure that the right person is accessing the right tools at the right time. Once we've talked about your level of trust, it's really important also to understand that with lower level of trust comes more level of automation that you need to do. So if you have zero trust methodology, there's a lot more that you need to automate across your whole stack. If you go with a fully trusted model, you're going to leverage more automated workloads. But no matter where you are on that trust scale, plan to integrate security automation across your DevOps pipelines. And that's really, really, really important to ensure that you're doing that from the start. Retrofitting that later on becomes quite hard to do that. And the reason why I mentioned that is because moving to containerized workloads adds additional attack vectors to your workloads and to your environment. And having the right security posture from day one reduces your threat vectors when you're deploying workloads and containers, and also gives you the right level of visibility in terms of the right things that you need to focus on as a security team as well. So with that in mind, what are some of the vectors and what are some of the threats that we see on our containerized workloads? So if you have a look at the container security threats that we see, there's probably 6 main categories that you really need to deal with. The host security, which is the host that's hosting your containerized workloads. The images themselves that you are deploying as part of your containerized workloads. How to deal with things like denial of service. How to deal with things like credentials and secrets. Container breakouts, which is privilege escalation across your containers, and runtime security as well. Even though every single one of them is a discipline that we can talk about for quite a bit of time, these are kind of the 6 main categories that you want to look into when you start talking about embedding security as part of your DevOps. How do we ensure that our hosts are secure, our images are secure, denial of services is being mitigated against, we have the right way to deal with our credentials and our secrets, and how do we actually ensure that our containerized working with the right level of privileges and there's no way to escape from that. So if we have a look at some of these topics in terms of how we can actually build that from a DevOps perspective, probably the most important thing to start looking into is your container images. And we typically refer to this as less is more, right? So the less layers that you implement as part of your containers, the more secure they are. The less open source libraries that you rely on as part of your stack, the more secure your containerized workloads in them. Some basic things that we expect you to do to ensure that your containers are secure, ensure that there's no secrets that are hard-coded as part of your code. Do not mix services. Typically, mixing services within one container is a bad strategy due to the fact that you can't do auto-scaling independently, number one. And number two, you're also mixing libraries of multiple applications. You also want to minimize your container footprint from a deployment, from a speed, and from a performance. And you also need to include only what's needed at runtime. So these are some of the things that you want to take into practice, and these are some of the things that you can automate as part of your DevOps pipelines when you're talking about containerized workloads. Also, when we start talking about images, referencing the parent image is also a really important topic. If you want to start with some additional best practices when it comes to container images, you want to be able to use known and trusted based images. Let's say, for example, that you are a Red Hat shop and using the Red Hat published base images, and you trust that source, you can actually enforce that all your base images are coming in from a trusted source. Besides the fact that you want to be able to use trusted sources, you want to be able to scan these images for CVEs. Imagine a scenario where you publish an application and your containerized images are all patched and there's no vulnerabilities. And within one day, a 0-day vulnerability appears with one of your Alpine containers, for example. You need to have the right mechanisms for you to be able to detect this. And once you are detected this, you have the ability to take action accordingly, whether that's automating these images or denying access to these images from a deployment. There's multiple different methodologies that you can implement to ensure that you deal with these vulnerabilities across your containerized workloads. Specify user in the Docker file. If you don't do that, essentially your Docker container is actually running as root. And there's no reason for your Docker containers to run as root. If they are running as root, I will start investigating why it's running as root and how we can actually mitigate against that and change that. And then you want to be able to use unique and informative image tags. So when I look at a container image as part of my container repository, a container image repository, I need to be able to understand what is it used by, is it a production image, and what type of workload that is associated with. Also to be able to tell which commits at a glance as well. So that kind of, these different types of practices, at least from a security perspective, gives the security teams and the development teams the right tools for them to be able to understand the base images that are being used and how they can utilize them moving forward as part of their workflows. There are some additional tools that are available for you to be able to integrate. All these are kind of open source tools. So Docker linting, validation of Docker configuration, or header lint and Dockerfile lint as well are different tools that you can use from a linting perspective to ensure that the configuration as part of your containerized workloads is valid. Secret scanning in images. So TuffleHog and Git Secrets are two really good tools to ensure that there's no secret keys or AWS keys or additional identifiers that are putting as part of your containers to ensure that there's no security security gaps that you're missing. We also, from a native AWS perspective, we do have ECR, which is our Elastic Container Registry, which gives you the ability to scan those images on upload and on commit as well. So you have the ability to scan those images, and if there are some CVEs, you have the ability to take action. And I'm going to show you a quick pipeline in terms of what that looks like. Vulnerability scanning of your images in your build pipeline is also a really good, there are a couple of really good tools. CoreOS Clear, which is with a backend database that gives you the ability to scan for specific CVEs and vulnerabilities within your images, and also the ability to take action accordingly. So kind of moving on a little bit to some of the tooling that we want to be able to implement as part of our container pipeline. This is a really good example of multiple different teams using the same tool set for them to be able to achieve that security end-to-end goal as part of your pipeline. Whether you are going to be using native AWS tooling from a pipeline perspective or third-party tooling, I think the same concepts apply. A good example, using code commit, which is basically our source repository from an AWS perspective. You've got your developers committing their code and the task definitions and the Docker files. The security teams have the ability to inject the security metrics as part of the pipeline like check the Docker file.py, or the ability to do yum updates to specific images as part of the deployment, and also the operations engineer for them to be able to inject their operational metrics and their operational visibility as part of these pipelines. And then using tools like Code Build essentially gives you the ability to package your code, build it on the fly as part of the pipeline, validate the build before you push it down into your containerized workloads. Within the Code Build step, you can validate the configuration, and based on that validation, if it's successful, you can merge it, scan for secrets as an example, merge it, scan the Docker image for vulnerabilities and CVEs, and then publish the image into things like EC2 Container Registry. So these are some of the different tools and some of the different practices that you can take as a security team and as a development team to ensure that the different parties that are involved as part of your pipeline, which is typically your development, your security, and your operations teams, are using the same tool set for them to be able to achieve that security goal. Credentials and secrets, leverage the tools that are available for you to make your containerized workloads secure. Parameter Store and Secrets Manager are two examples that AWS offer, and there are a lot of different offerings that are happening with different vendors as well. But it gives you the ability to store your secrets outside of your containerized workloads. And the idea behind it is that you're leveraging APIs and leveraging identities and IAM roles for you to be able to retrieve these secrets and use them as part of your operations within your containers. The great thing about this decoupling is that vulnerabilities in your containerized workloads doesn't directly affect your secrets, and having that decoupling gives you that additional level of security where the data is being secured in a different service. Assigning an IAM role to an instance basically gives you the ability to call these services and generate temporary credentials. We use a functionality called SIG4V in terms of signing every single request from an identity perspective. We issue temporary credentials for 60 seconds for specific operations, and that gets renewed automatically in the backend. So it's a much better way for you to be able to use those temporary credentials and rotate that level of access on a regular basis to ensure that your containerized workloads are separated from your secrets, which is a really big concern for a lot of security professionals when it comes to containerized workloads. So let's put that all together as an example from an AWS perspective. This is a really good example of a pipeline where you are embedding security as part of that. So as an example, when the developer commits his code into things like code commit or GitLab or Bitbucket or whatever it is that you want to use from a source repository, that would trigger your pipeline. And based on that pipeline, you can actually go through the multiple steps that you want to include from a security perspective. Docker linting, secret scanning, vulnerability scanning, and image build. And then you can actually, based on that pipeline, publish the results into tools like AWS Security Hub, which is our centralized security service with all the different findings that we have. And that gives you the ability to take automated action, to be able to auto-remediate, jail certain container images based on the different metrics that are coming out. And then you can also, from a loop perspective, push back all these results using Amazon CloudWatch and leveraging things like Lambda function to be able to add feedback into your pull requests. So you can take actions as part of that pipeline to say, if there are some vulnerability scans, we're going to be failing that pipeline, pushing the feedback back into our developers saying, you cannot deploy this pipeline into production due to the fact that you have some vulnerability scans, or I found some secrets as part of your code, and it enforces the developers to go fix that. So again, to summarize, the idea behind embedding security as part of your DevOps pipeline is involving all the different parties, having the right tools, and the same tool sets that are being used by the development team to be used by the security team to ensure that we have that right feedback loop and the right collaboration between the teams. So if we kind of summarize a little bit some of the topics that we discussed, the 6 different kind of threat vectors of containerized workloads, it's important to understand that security, besides DevSecOps, is defense in depth. You want to be able to secure your environment on multiple different layers to ensure that even a misconfiguration in one of the layers does not dictate a weakness as part of your overall strategy. So if you have a look at, for example, from a user data perspective, having the right mechanisms to ensure that there's no personally identifiable data or leaks or the ability to scan your data accordingly There are a lot of different tools that give you the ability to do so. From a configuration perspective, ensuring that there's no passwords or API keys or clear text passwords that are being saved as part of your configuration. And from a source code perspective, static code analysis, sanitizing the user input, etc. And from a dependencies perspective, is the source available? Is it a trusted source? Doing some code analysis and the huge surface across many languages. That's also a really good concern. Some organizations use multiple different languages in terms of how they build their containerized workloads. It's a really good practice to reduce the surface and the number of languages that you're using as part of your development, to have a smaller surface of attack and smaller surface of operating systems and libraries that you have to update and work with. From a container side, we talked a little bit about this, securing it on a runtime perspective, having the right standards, immutability of your images. All containers have a shared kernel, and some of the different things that you want to ensure, like unnecessary privileged access and trust, etc. And finally, the host that's actually running containerized workloads, taking care of things like multi-tenancy across multiple different availability zones, Linux packages, CVEs, and all the different security mechanisms that you do on a typical host level. And with that, I just want to kind of end with some of the best practices that we've published from an EKS specifically perspective, because it's probably the most widely used from an AWS side of things. We have a detailed guide. If you search for EKS best practices for security, we actually have a well-detailed guide that guides in terms of how to secure your containerized workloads across all these different vectors that I spoke of: infrastructure security, runtime security, detective controls, etc. So it's a really, really good practice to go through this guide and ensure that you're implementing as much as possible of these practices as part of your containerized strategy. And with that, I'd like to thank you for your time. And